Okay, hopefully everyone can see me and hear me. I think everything's set up properly. Let me know if you can't hear me or see my screen or anything. I'll get started in a minute. Okay, so there's only a few of you. If you recall, I think I introduced myself in the very first lecture. So my name is Steven Thornton. I'm the TA currently for this Intro to Data Science course. And these tutorials will be run weekly every Saturday at 10:30 a.m. Eastern Time. And the idea of the tutorial is just to give you a chance to ask any questions you have, and I can give you feedback. And maybe I'll go through some examples and things of that sort. So today I'll probably go through some ggplot stuff, just because it's fairly useful to know how that works. If there's any specific questions you have, just let me know. You can just write in the chat window. That's probably the best place to give any feedback. And just let me know if you have any specific questions. The tutorial sessions are really meant to be a little more interactive, so to kind of, if you are having difficulties with anything, let me know, and then I can give you feedback about that. Can't hear me. Okay. Is it that you can't hear me or that you can't? Let's see. Okay. Everyone can hear me all right? The cat is scratching at my door. Sorry, I'll be back in 1 second. Okay, so hopefully everyone can hear me all right. Can everyone see RStudio in the RStudio window I have open here? Just make sure that's actually sharing. Should be. Chat again. Okay, hopefully it's big enough to make it a little bigger. So I'll just kind of work through a few examples of using ggplot. If you haven't already installed ggplot, again, like anything in R, you can install it using installer packages. And then it's called ggplot2. GG stands for Grammar of Graphics. And if you just hit return there, so that'll just install it from CRAN, which is the repository for all of the R packages. So at this point, it'll be installed. It hasn't been loaded yet. So to load it, you can just do library ggplot2, and it will actually load that for you. I'll actually do all of this in a file. So this is just the console down here. It's typically a good idea just to try and do everything in an actual file. That way you kind of have a better history of what you've done. Like you can, if you just hit the up arrow, you can go through all of everything you've previously done down the console, but this way you have everything saved all in one place. And to run it, so mine's kind of zoomed in, so it's a little hard to see. You can either highlight code and hit, on a Mac it's Command Enter, on a PC it's probably Control Enter. That will just run that line of code, or if you have multiple lines, it will run multiple lines. So at this point, ggplot is open, or sorry, is loaded. You'll notice over here environment variable, so it doesn't have anything there. If I go down here, I type MPG, which is the miles per gallon data set, you'll see it print something. So ggplot will load some default data sets for you. They can be fairly useful. So in order to actually see those, so if you recall before, for your environment, you could do something like x equals 10, and it shows up with x over here. Y is x plus 2. and now Y shows up over here. All of that ggplot stuff, it's kind of hidden in here. So you'll see it says global environment here. If you click on that, below that you'll see a list of packages. So ggplot2 is there. There's a bunch of other packages. All of those other ones, with the exception of base, those are all loaded by ggplot2 when you load it. So often when you load a package, several other packages will also load at the same time. So in this case, it loads stats and a few others for you. So if you hit ggplot2 there, it's a little hard for me to see. You're unable to see my screen. Okay. Let me double check that. Just try my screen. Okay, I'll start over then. Can you see my screen now? Just let me know. You should see RStudio open. Okay. Okay. Okay, now place will start. In that case, I'll start over. Back there. Clear everything. Okay. So this is just RStudio, which you should be familiar with. Top left, I just opened a new file here. And again, it's good practice just to have a file open. That way you can kind of record all your commands in there. So I'll just load library. I'll load ggplot2 there. If you've never used ggplot2, it won't be installed by default. So you'll have to actually install it. You'll end up spending a lot of time doing this anytime you try out a new package. You'll have to install it. So you can do install.packages and then ggplot2. In that case, so it'll go through the whole process of actually installing the package for you, and then it'll actually be available for you. And there's also this little packages tab in the bottom right window. It has a big list of packages there, so you'll see somewhere in here it's ggplot2. So ggplot2 is there. A lot of these are just kind of your more common packages. I think they're just ones you have installed. Yeah, and then it allows you to update packages and things of that sort as well. So once you have ggplot2 up and running, so here, so you can just highlight the line and hit Command Enter on a Mac or Control Enter on a PC. You can do that for multiple lines, and it just runs those lines of code. So it's fairly useful, just kind of quickly get things running. So over here in the environment, so if you recall, that's where it shows all your variables. So you could have like x is 10, y is x plus 5. It just shows your variables and their values. If you have a data frame or a data set, it'll show up there. If you define any functions, they'll show up there as well. You'll see it says global environment up here. So ggplot2 will actually load some data sets for you, as well as a whole bunch of functions for plotting. So I'm going to get rid of that. 1 second. Okay. So ggplot will load a whole bunch of stuff for you. And to actually see that, so if you click global and variables, there should be a drop-down menu. And it'll give you a list of stuff. So you'll see ggplot2 is there. A whole bunch of other packages are there. So there's like graphics, some other graphic stuff, utilities, and a few other things. And ggplot just loads those by default because they're packages that ggplot uses. So if you click on ggplot, you should see a whole bunch of stuff. So you'll see under data, I now have MPG there. If you don't see MPG, you can just type MPG in. And it should actually load the data for you. And there's a whole bunch of other stuff. These are all just the functions, variables, everything that come with ggplot. So there's a ton of them there. Kind of go forever. All the functions and everything there. So this MPG data set, and again, kind of when you're first starting with the data set, often it's useful just to look at the actual data. So similar to, you can just open up like an Excel file and kind of scroll through your values. It's the same sort of thing here. So if you just click on data, if you click on the blue arrow, it'll give you a little drop-down menu. That shows you each variable plus the values that are in it. But if you just click on it, it'll open up over here a window. So here we see we have a whole bunch of columns. So it looks very similar to an Excel spreadsheet. So we have manufacturers, there's a bunch of different manufacturers, model of the car, and then some other variables to do with that actual car. class, things of that sort. You can sort them, so if you click here, so CYL, that's the number of cylinders. If you just highlight over it, you can see the range of the number. You can sort it, increasing, decreasing, things of that sort. So it's often useful just to leave this open. And you can also do things like you can look at the summary of the entire data set. It kind of cuts off here. If you have a lot of variables, it can be useful to look at that one variable at a time. But in this case, so we see the summary. So manufacturer has 234 values. Its class is character. Same thing for model. Displacement, in this case, because it's a numeric value, it'll give us the minimum, maximum, median, mean, and the quartiles. Year in this case actually gives us the same thing. So it gives us the median year is 2004. Number of cylinders is, again, the same idea there. Transmission, again, just tells you all the information about all of your variables. So usually, depending on the size of your data set, if you have a data set that has a lot of variables, it's going to be difficult to actually go and plot all of them. But often it's useful just to start plotting stuff. So with ggplot, you can just do ggplot. That is miles per gallon. And if you just run that on your own, so that's kind of how you would start. That's the starting process to actually plotting this data. It's not going to show you anything. So in this bottom right window, you want to make sure you're on plots. You'll see there's nothing there. So that's because we haven't actually plotted anything yet. So in this case, we can do, if we wanted to create a scatter plot, so I think it was scatter plot of highway versus cylinder as one of the exercises. You can do plus geom point. So I'll just create a point plot. There's a whole bunch of these geom things. There's ones for making line plots, bar graphs, histograms, heat maps. Basically anything you could ever need is somewhere within ggplot. A lot of the time you have to kind of look to see where it is. There's various cheat sheets. There is a good ggplot cheat sheet somewhere that kind of summarizes all of the really useful ones out there. So in this case, we do mapping. You can actually do this on a new line, just to make things a little cleaner. So mapping equals AES, and then we just say what our x-axis is. In this case, we'll do highway, and our y-axis is cylinders. So again, if you just highlight that and run it, you'll get this little point plot here. So in this case, the number of cylinders can only be 8, 6, 5, or 4. So there's no cars with 7 cylinders or 7.5 cylinders. So you'll see it kind of lines up in a slightly weird way here, but you see the highway variable, which is the fuel efficiency on highway. It seems to increase as the number of cylinders decrease. So there seems to be some sort of trend there. And again, this is the kind of analysis that you typically do when you first start with the data set, is to look at your variables, see is there any sort of relationship there, which variables have relationships between them, and other things of that sort. Okay, another one of the examples, this is exercise 3.3.1. So it's the same thing. This time they did axis displacement. Sorry, it kind of cuts off here a little. Axis displacement y is highway, and in this case the color is blue. So you can also set up the color. We'll just do it like that. You can also set the color using this. Those are not blue points. That's interesting. Okay, those should be blue points. I'm not sure why they're showing those red points. Maybe COL. Nope. Okay. So they seem to want to show up as red points. They should show up as blue. So I'm not too sure what's happening there. Oh, why are the points not blue? Oh, okay. Oh, okay, so the points, so color's a little bit weird. So we could do color is equal to CYL. In this case, the color, keep color outside. Sorry. Color. Well, it comes out. Color equals blue. Okay, I'll try if I can spell color. Let's try that. Okay, so now they're blue. Okay, yeah, so this is a little bit, there's various ways of doing things. So in this case, the color goes outside of the AES function, so we get color equals blue. That will color all of the points blue. Another thing you can do, I'll just copy and paste this. Rather than coloring them as blue points, you can do color equals CYL. In this case, it goes within the AES because we're referring to one of those columns of the actual data frame. And in this case, you'll see the color kind of changes depending on the point. In this case, the color is based on the number of cylinders. So black presumably means 8 cylinders, and then it kind of continues from there. So there's a lot of different ways to color things, depending what you want to do. See what else I want to do. Any questions on any of that so far? Just kind of getting up and running with ggplot. Just give people a second to write. Okay, another really, can we please go to stat? It's similar to graphic function. So the stat summary ones. Find those. Stat smooth and stat summary. All right. Believe so data is, make sure I do this right, plus stat summary mapping equals, I think, let's see if I actually do this correctly. Y equals, okay, let's try this and see what we get. Okay. No summary function. Stat smooth. Okay. I'll start with stat smooth. And then stat summary, I think maybe we'll start with stat summary. Okay, so stat summary. Stat summary just makes a point plot. In this case, just showing you variables hidden for me there. Stat smooth, on the other hand, can actually be fairly useful. So we can do one with that. Stat smooth. So if I do stat smooth, what it will do, so it'll fit a smooth curve to your data in this case. So the data is not actually being shown here. But if it's a smooth curve, which is the blue curve there, and then this gray curve, I believe, is 1 standard deviation on either side of that blue curve. When you use stat smooth, so you can also throw your points on there, so we can do geom point mapping equals yes. So if you add your points on there, you can get both your points plus this smooth curve, so you can kind of see. It's a little bit tricky here. The order you do them affects what's plotted where. So if I do this, the blue line should be on top. If I do that, okay. So if you do it the opposite way, then the blue line's on top. Just makes it a little bit easier to see with the points there. So in this case, you can see out here, so that gray area increases a little. And that's because the variance of the data increases out there. Whereas further down, the variance isn't as large. These can be really useful, again, if you're trying to analyze some data, you're trying to make, we're trying to make some sort of prediction about the data. It's useful to make these sorts of plots to see, is there any sort of relationship? So sometimes you might just get data that looks completely and totally random, in which case you need to decide, is there some sort of a relationship there? If you use something like stat smooth and you get something that's not just a horizontal line, then you can kind of conclude that maybe there's some sort of relationship there and there's something worth looking into. All right, question: stat smooth versus geom smooth. Geom smooth. Let me see what the difference between the two is. Not sure if there is much of a difference. Yeah, so from my understanding, stat smooth and geom smooth will do the same thing for you. Just looking at the help page on them, because I don't think there's any difference between the two. So if I had done this as with geom smooth rather than stat smooth, yeah, so it gives you the same thing. There might be some sort of subtle difference between the two that I'm just not really aware of. There's kind of a lot available to you within ggplots, so if there is some sort of subtle difference, it's possible. Again, it's something that might only present itself in kind of very specific types of applications. So I wouldn't worry too much about the difference between the two there. Same with stat summary. I think it's pretty much analogous to geom point. Okay, onto facet grid. Let me just scroll down a little. Just close that. Okay, facet grids. I'll just do an example one first. So this is again just taking, this is example 3.5.1. This is data equals per gallon. You actually don't have to write the mapping thing every time. You can actually just do AES. Same with data. You can actually just write MPG, just kind of a short form. Okay, so let's quickly just run this. Get some picture of that. So in this case, we're doing a facet grid will essentially create multiple plots for you based on, in this case, some sort of categorical variable. So we go back and look to see this DRV. So it's either four-wheel drive, four-wheel drive, or might be rear-wheel drive in there somewhere. Just highlight over it. Let's see if it's actually rear-wheel drive. I think you can do PG at DRV. I think you can do levels. No, okay, that's not gonna work. Let's try summary. Okay, that's not telling us there. So facet grid, in this case, DRV, so we either have four-wheel drive, four-wheel or rear-wheel drive. So in this case, we get to visualize the differences between, if we plot point plots for displacement versus highway. For each of those different categories, it will show us, like, for example, maybe with four-wheel drive, maybe we have an increasing relationship between displacement and highway. Maybe for rear-wheel drive, we have a decreasing relationship. In this case, we can kind of see, so four-wheel drive, you can kind of connect that with a line. Four-wheel drive, same thing. Rear-wheel drive, kind of a little bit more scattered. So it just lets you identify cases where among categorical variables, things differ in some way or another. We can also do this for, the other example was, I'll explain this dot tilde thing in a second. We can do it in comparison to the number of cylinders. So in this case, you can either 4, 5, 6, or 8 cylinders. So you can see for 5 cylinders, it's only what looks like 2 points there. And then you can kind of see for 4 cylinders, the displacement is a lot lower, whereas 8 cylinders were up a lot higher here. So it just lets you identify the relationships between these in a much easier way. You could also have done the color equals CYL. We could have done this instead, which shows us the exact same information. It's just when we start to get points that overlap, in this case, it can be a little bit more difficult to see the differences, or if you have many categorical variables or there's a lot of overlap, it can be different. It can be difficult to actually see. So by actually separating them using this facet grid thing, you can very clearly see the differences between them. So we see there's only 2 points corresponding to 5 cylinders. So 5 cylinders probably isn't a great predictor for anything because there's not much data there. So they'd be really useful. The difference between, in this case, we had DRV and the little tilde and a dot. So in that case, it stacked them. So each plot made up basically a row of a grid. In this case, dot, little tilde cylinder, each plot makes up a column of a grid. So that just decides how you actually want facet grid to plot things. Okay. So yeah, facet grid can be very useful. It's a good one to know how to use. Let's see. Histograms. Histograms are good too. Let's do a histogram. Okay, so we could do a histogram. Let's do a histogram of highway. Okay, so histogram, not too much different than what we've been doing. So again, our data is miles per gallon. I'm just using the short form here. In this case, we have geom, histogram. For AES, when you're doing a histogram, you only have one axis, so you're not plotting something versus something else. You're only plotting one variable. So in this case, we can do x is highway. I'll give you a little warning saying it's just using the default number of bins. So in this case, we get an actual histogram of the data. Depending on how you're modeling things, sometimes you might want data to look normally distributed. It's a good way to identify values that are kind of outside of the norm. So we get these values down here. They're not too bad. Sometimes you'll have histograms of values that are really far from the rest. So it's good for identifying those. You can also change the number of bins. We can do 100 bins. And in this case, so splits into 100 bins. Most of those bins are just empty, which is why there's gaps. So histograms, again, are really good for looking at various variables. I think you could even do geom, or so you could even do facet grid with this probably. Let's reduce. I'll get rid of the 100 bins. Facet grid. Do cylinders again. Should work. Yeah, so you can plot histograms for various numbers of cylinders in this case. Just for displacements, we're not doing a point plot anymore. We're just doing displacement only. And it basically just gives you the same kind of information that you had before. So you can see the highway efficiency is a lot lower for 8 cylinders versus 4 cylinders is a lot higher. And all of these scales will be the same. So it keeps them all the same, which makes it really easy to compare across various plots. Let's see what else. Okay, another thing. Again, this is separate from ggplot. So for this case where we have 5 cylinders, we might be interested in knowing how many points are actually in there. So we could look at miles per gallon, CYL. So if we just do that, oops, MPG, not MPL, it'll print out that entire column of the data frame. So if we again go here, top, to miles per gallon, we go to CYL. So we'll see it's just printing the entire thing. It'll cut off at about 1,000 values once it's printed them. In this case, miles per gallon only has 234 rows in it. But in this case, maybe we want to know how many of those are equal to 5. So if we just did a doubles equal sign equal to 5, if you just run that currently, you'll get this big long vector of 234 values, some of which are true, so the true is there, a lot of which are false. What we can actually do, we can actually sum it up. Basically, what summing that does is if it's true, it equals 1. If it's false, it equals 0. So summing miles per gallon of cylinders equals 5. That just tells us how many values in that cylinder column are equal to 5. So in this case, we know there's only 4 values that are actually equal to 5. So it can be useful again just to get some information out of your actual data frame. If you want to know how many rows are in your data frame, and row .mpg 234. Sometimes, depending what kind of code you're writing, is useful to actually be able to write that using code rather than looking over here to see. You can also get call names mpg. So that'll print out all of your different columns, what they're equal to, or sorry, just what the names of them are. Again, fairly useful. You can create new columns. So you could do like pg at you can do like cylinder times highway, and we can just do that. So keep writing mpl pg at cylinder times mpg at highway. So you create a new column that's just the product of those two columns. It can be useful to create columns like this. So some types of transformations are more useful than others. Like you might want to take a log of a column because maybe the log is normally distributed, whereas the original value is not. Things of that sort. Doing that over here, you have to refresh the data. So you'll see there's this new column called cyl.hwy. If you're familiar with programming, if you use Python, never use a period in a variable name. In R, you're allowed to, and it's actually used fairly often. R is kind of the only language where you can do that. So that will create a new column for you. It's pretty much most of what you need to know in terms of actually manipulating data sets. Let's see what else I wanted to do. Okay, so that pretty much covers everything that I kind of had planned to go over. Again, being familiar with ggplot is one of those things, the more you use it, the more comfortable you get. Anytime you need to know something, you can actually typically just look it up. There's lots of good information online. Some things are a little bit more difficult than others. I think the other day I was trying to make a bar chart where I was actually sorting things in decreasing order. Something like that. You can do it. It's more difficult than it probably needs to be. Actually, I'm going to put a link in the... Okay, so I just put a link in the chat. That's a ggplot cheat sheet. So it's really useful just to very quickly look up different types of plots, different types of things you can do. There's a whole lot of stuff within that actual cheat sheet, but again, it's fairly useful. I think it gives you all the various themes as well. So yeah, there's themes within ggplot. I'll show you an example. Themes just change the way things look. Theme underscore, so do theme, that's minimal. So if you do that, you'll see it looks different now. So it no longer has kind of that gray background. I'm not really a fan of the gray background, which can just be nice for making things a little bit nicer to look at. The cheat sheet itself just has a ton of information on it about everything ggplot related. Okay, so is there any other questions about anything that I've covered? I'll probably upload this this file here, so you have access to that. And again, it's good practice just to go through. So you can see in ggplot there are some other data sets here. There's one called diamonds, which has like 54,000 rows in it. And again, it's good practice just to go through things like this and maybe like make a histogram of the chars. You like ggplot diamonds plus John. Histogram. So doing something like that. So in this case, we see that it doesn't take that shape of a normal distribution. It's kind of skewed to the left a little bit. You can't have a negative number of carats for a diamond. There's a ton of other ones here. There's also, I believe, a library called datasets. You'll have to install it. It's not one of the default ones. Again, if you go here, go to datasets. Again, there's a ton of different datasets here. It's good practice to explore them, get comfortable with using them. Kind of think, okay, if I had an earthquake one, if I hadn't, maybe that's not a good one actually. There's one on rocks. And just kind of explore the variables and see see what's there, plot it, and try to think of what else. If you're trying to make some sort of prediction, what other things would you want to actually do with that data set? There's one on air quality. So you could try to predict like the ozone level based on a bunch of other stuff, something like that. Parameters. Yes. So this is in response to the question in the chat. Yeah, so the parameters, if you ever go to one of the help pages for something like points, for example. Yeah, if you ever go to one of the help pages, it can be overwhelming how much stuff there is, but yeah, so these help pages aren't always the best to look at. So it's like ... here. Things like color, you can change the size of points. So we did find that. So we did a point plot. We could have done size equals 0.1. Yeah, so these are all just parameters you can change, just tons of different things. Do size equals 0.1, or you can even do the size based on some other variable. So in this case, that's go within the AES. So I think CTY is a city versus highway, miles per gallon. In that case, they're all huge. Yeah, so there's a ton of different parameters you can change. For the most part, don't worry about trying to make plots that are super stylish looking. You can kind of stick with the default parameters. Just focus on analyzing the data and recognizing relationships and those sorts of things within your data. If you ever have to make a presentation, you want to make it really nice looking, you can kind of spend more time doing things like adding a title. You do like X label, in this case, displacement, adding things like this, Y label, that I think is highway miles per gallon, Y label, I think title, yeah, title, plot of thing. You can also change things like the X limits. So for example, xlim, if you only wanted the X values to range from 3 to 5, 3 to 5, do things like that. Okay, the title doesn't want to work. Might have to do that again. No, it's not. Okay, ignoring. Oh, title might have to go. Yeah, facet grid might have to be the last one. Nope, okay, it doesn't like title for some reason. I don't know why. But otherwise, so you can see the X and Y axes change here. The X limit is probably a bad idea. I can't see anything. But you can change your X and Y limits. You can scale things logarithmically, so there's other stuff like scale _x log 10. If you ever need to scale something logarithmically, you can reverse things, so scale x reverse or square root. There's special things if, for example, your x-axis was dates. Maybe you had, for example, the air quality one. Maybe you had the air quality over the course of years. So it goes from May 1st up until I guess it's September 30th. So you can make your x-axis look nice based on dates. You have to use date time objects within R to do that, which can be a little bit complicated. That's basically everything. Anything else? Any other questions on anything? Let me do that for the diamonds one. Do a histogram for the diamonds one again. Caret. And I could do scale. So maybe we'll do a point plot. Let's do caret versus price. Caret y equals price. So let me just create a plot of that, see what it looks like. There's a lot of points, so it might take a second for the plot to actually show up. This one has like 50,000 points. Kind of an interesting looking one. But then we can scale x logarithmically, we can scale y log 10, just for fun, basically. So we can scale them both on a log scale, see if it gives us anything useful. In this case, so it actually looks a little bit more like a line now than it did before, so sometimes scaling things logarithmically can be useful. Okay, so there's no more questions on anything. I think I'll end things there. Again, you can always email that instructor@acads.org email address. If you ever, as you're going through things, if you have questions or issues on anything, feel free to email us there, and someone will get back to you. And then lecture tomorrow, normal time. I'm not too sure what's being covered tomorrow, but I will see you there.